So we have come to the second part of this same question. Now this is the third question under calculus. The third question was the first question under calculus, and these are what you want to be doing. The first one says evaluate the following limit as x goes to 1 of square root of 5x minus 4 minus square root of x all divide x minus 1. Then the second one as well, limit as x goes to 2 of x squared plus 2x plus 1 and all over x squared plus 3x plus 2. Then after that, you are told to evaluate the integral of the square root of a squared minus x squared dx. Then lastly, we are told to obtain the reduction formula for tan n of x. At the same time, you are told to evaluate tan 5x. Should take the integral. So let's look at how we are going to be solving this problem one after the other. Now, the first one, limit as x goes to 1 of square root of 5x minus 4 minus square root of x divide x minus 1. Now, whenever you are evaluating the limit, whenever you are told to evaluate the limit, as x goes to maybe any number, you put that number into the function given first. If the answer you get is not undefined, I mean if it's not 0 over 0, if it's not infinity divided infinity, or if it's not any number divided infinity, then that is the limit of that function. But if you have either 0 over 0, or infinity over infinity, or maybe a number divided by 0, any undefined number, then you need to maneuver your way around. Now, if I put 1 inside this one, I have 5 times 1 will give me 5, obviously. 5 minus 4 will give me 1. So I have square root of 1, the minus square root of 1. Obviously, the numerator will be 0. Divided by 1 minus 1 again, the denominator will also be 0. So I can't put the value there. I need to make some I need to do some other things so that I will get a proper answer. You get my point? Now let's see what we are going to do. In this case, this is what we are going to do. I am going to evaluate, I will just rationalize. Whenever you see a number like this, just try to rationalize the numerator. So rationalize the numerator, then you will get a very good answer. Let's see how it goes. Now I have limit as x goes to 1 of square root of 5x minus 4 minus square root of x divide x minus 1, and I multiply by square root of 5x minus 4 plus square root of x. So basically, how we evaluate, so that's how we are going to be doing this as well. We evaluate so by multiplying both numerator and denominator by its conjugate. The same thing here. Of course, I am rationalizing the numerator here, so I multiply both numerator and denominator by the conjugate. So the sign in between will change, and the numerator will become by difference of 2 squared. What's the difference of 2 squared saying? When you have a minus b multiplying a plus b, by difference of 2 squared, it will become a squared minus b squared. So this is a minus b is multiplying a plus b. So I'm going to be using difference of 2 squared to evaluate or simplify the numerator, while the denominator I'll just multiply normally. So this will become limit as x goes to 1. The numerator will now become square root of 5x minus 4 all squared minus square root of x all squared divide x minus 1 square root of everything multiplying 5x minus 4 plus square root of x. So by the time I'm done with the numerator becomes limit as x goes to 1 of the square will cancel the square root actually. The square will cancel the square root. I have 5x minus 4 then minus x. Obviously the square has cancelled the square root divided by x minus 1 square root of 5x minus 4 plus square root of x. So if we simplify the numerator very well, I have limit as x goes to 1. 5x minus x will give me 4x. So I have 4x minus 4 at the numerator divided by x minus 1 square root of 5x minus 4 plus square root of x. And that will be equal to limit as s goes to 1. 4 is common at the numerator. By the time I factorize, well, I will be left with x minus 1 there. Divide x minus 1. Then I have square root of 5x minus 4 plus square root of x. So x minus 1 will actually cancel out. So I'll be left with 4 divided by square root of 5x minus 4 plus square root of x. Then I'll put 1 there. I'll now put the limit. So this one will become 4 divided by square root of 5 times 1 is 5. 5 minus 4 is 1. So square root of 1 plus square root of 1. Square root of 1 is 1. 1 plus 1 is 2. So 4 over 2. And the answer is 2. So the limit as s goes to 1 of that first answer, the answer is 2. Let's come to the second one. Limit as s goes to 2 of s squared plus 2s plus 1 divide s squared plus 3x plus 2. So basically, put 2 in this expression given in this rational function. If you don't have any of these things, then that's the answer to the limit. So I put 2 here. 2 squared will give me 4, that's 4 plus 2 times 2 again will give me 4, 4 plus 4 plus 1. 2 squared will give me 4 plus 3 times 2, 6 plus 2. So that's very good. 4 plus 4 will give me 8, 8 plus 1 will give me 9. Divide 4 plus 6, 10 plus 2, 12. 3 can go and I'm left with 3 over 4. That's the limit as s goes to 2 of the second function. And that's all for this first part actually. So this part you can see is very simple. It's not difficult. This question 1 will actually carry more mark, maybe 3 marks, then this one will be 2 marks, or this is 4 marks, or this is 1 mark. This is what you will actually need to show. Do you understand? Now let's come to the. We want to evaluate the integral square root of a squared minus s squared ds. So basically in this question, we want to evaluate the integral of square root of a squared minus s squared. So in this case, this is what we are going to be doing. We're trying to take away the square root. And actually, whenever you see questions like this integral, either at the numerator or at the denominator, just think of trigonometric substitution. So the trig identity that will help you to remove the integral at the square root, that's what we are going to be using. Most especially, whenever you have integral like the square root of a squared minus s squared, what should come to your mind is this substitution I'm going to write on the board. At times you might write square root of 9 minus s squared ds. So this is what you are going to do. You will let x, you see, you have s squared here, so you will let x to actually be equal to what is here without the square root, a sine theta. That's what you are going to do. So if you do this, the rest will be fun. You just substitute and you will see that you will get the integral appropriately. So whenever you have questions like this, 9, a number minus s squared, know that this is the substitution we are going to be using to evaluate them. Now let's continue. I have let s be equal to a sine theta. We differentiate the s is equal to a cos theta, the theta. Mind you, there are some things you need to do here as well. Of course, you have looked for the s is equal to a cos theta. Now, what is sine theta? Make theta the subject of formula. If you want to make theta the subject of formula, you first make sine theta. Sine theta is actually equal to x over a, right? Then theta will be equal to arc sine of x over a. So we have established that already. Now let's come to the integral. The integral says integral from square root of a squared minus s squared dx. So that's integral of square root of a squared minus x. S is a sine theta. Alright, a sine theta all squared. So ds is multiplied is a cos theta. The theta, that's what the ds is. So this will be equal to integral from square root of, now if you look at this one will give me a square minus a square sine square theta. Then multiplying a cos theta in theta. So this will become integral, a is common, a square is common, I will be left with 1 minus sine square theta, multiplying a cos theta in theta actually. So square root of 1 minus sine square theta will actually give me cos square theta. So I have this is equal to integral of square root of a square cos square theta, and this is the multiplying a cos theta in theta. So this will be equal to integral square root of a square is a, obviously. Square root of cos square theta is cos theta. Now it's multiplying a cos theta in theta. So eventually this is what we are going to get. We have integral of a multiplied by a will give me a square cos square theta the theta, and this will give me a square will come out, then you are left with cos square theta the theta actually. So now what do we do here? We need to evaluate cos square theta. And what is cos square theta? Now you have to recall something. You need to use an identity to evaluate cos square theta. You need to recall that cos 2 theta is equal to 2 cos square theta minus 1 actually. This is one of the trig identity, especially by the use of the addition formula. So this will, by the time you make cos square theta the subject of formula, you will have 1 plus cos 2 theta. That's what you have, all divided by 2. That's what you are going to have. So you need to put this in that integral so that we have a square integral of cos square theta. The theta will be equal to a square integral of 1 plus cos 2 theta divided by 2 the theta actually. So what will happen from there, the 2 can come out. So we have 1 over 2 a square integral of 1 plus cos 2 theta. So by the time we evaluate this completely, integral of 1 the theta, that's just theta, obviously because I'm integrating with respect to theta. Integrate cos 2 theta, you have 1 over 2 sine 2 theta, and that's it plus c. So basically, if you look at the question we are given, there is nothing like theta in the question. So we are the one that bring in theta. So we need to put back what theta is. Theta is what arc sine of x over a. So this is what I'm going to do. 1 over 2 a squared. Theta is what arc sine of x over a plus 1 over 2. Now I want to get sine 2 theta. Actually, to get sine 2 theta, you need to also use another identity there. The identity to use is to know that sine theta is 2 sine theta cos theta. For you to be able to really evaluate integration very well, you need to understand the basic knowledge of trigonometry. Trigonometry is very of help and very useful while dealing with integration, especially integration, both differentiation and integration, but integration particularly and limits. Now, 2 we cancel 2 then. I have 1 over 2 a squared arc sine of x over a plus sine theta cos theta actually plus c. So I know what sine theta is. Sine theta is x over a, but I don't know what cos theta is. I will find it. So without wasting time from the trigonometry, actually I have shown you in the first part 101, that advanced pure math before now, that cos theta is actually equal to square root of 1 minus sine square theta. So that means I have 1 minus sine theta is x over a. S over a also will give me s squared divided by a squared. So that this one will give me a squared minus s squared divided by a. If you look at it from the LCM is a squared. So I will have a square minus s square at the numerator divided by a square at the denominator. So I separate the square root. So the square root at the numerator I have square root of a square minus s square. At the denominator I have square root of a square. Square root of a square is actually a. That's why I have a as the answer there. So now let me put it there so that the answer to that question, integral of square root of a square minus s square, the s will just be equal to 1 over 2 a square, open bracket, at sign, of x over a plus sine theta. Sine theta is s over a multiplied by cos theta. Cos theta is square root of a square minus s square all over a plus c. You can either answer this way or you can simplify further, whichever one is fine. If you want to simplify this further, this one would have become 1 over 2 a square arc sine of x over a plus 1 over 2s square root of a square minus s square plus c. I mean, if you just evaluate this and you multiply through by a square, you just open the bracket, basically you will get that answer, and that's the answer to this to that integral question. I hope you understand. Let's come to the third part, which is the last one in this place, the C part. We are told to evaluate this. Let's come to the last part. So the third part, you are told to, given in is equal to integral from tan nx dx, show that in is equal to tan n minus 1x, all divided by n minus 1, then minus in minus 2. So this concept is called the reduction formula. I have done the reduction formula for all three functions. You just go to my playlist, you will see reduction formula for all three functions, like reduction formula. So you should go there and check all reduction formula, including this tan nx. I have done the reduction formula before now. So just go there, check it out, because you might be given a different trigonometric expression to obtain the reduction formula. You might be given chord, for example. It's there already, so just go there and see how to evaluate the reduction formula. So I'm just going to be solving this integral of tan 5x. But to show this, actually I have showed this before. You just need to go to my playlist. I think I will put the link in my description box. So now let's evaluate this integral of tan raised to the power 5x dx. So integral of tan raised to the power 5x dx, that means n is 5. That's the first thing you need to take note of. N is 5. So that means you want to evaluate I5. So you are going to be using this reduction formula to evaluate this tan integral of tan 5x dx. So I have I5 is equal to, anywhere you see n, put 5. Tan 5 minus 1 will give me 4 divided by 4. Tan 5 minus 1, that's 4, divided by 5 minus 1, which is also 4, minus I3, because 5 minus 2 is 3. You will look for what I3 is as well. Using the same reduction formula, I3 will be equal to tan 3 minus 1 will give me 2 tan squared divided by 2 minus I1. 3 minus 2 is 1. What is I1? I1 is simply integral of tan raised to the power 1x, which is integral of tan x. So this will be equal to integral of sine x divided by cos x dx. So again, if you differentiate, if you have a rational function under the integral, if you differentiate cos, for example, differentiate cos, the answer is minus sine. So if you differentiate what is at the denominator of a rational function and you are getting what is at the numerator, the answer is ln of the denominator. So this is what I'm going to do, because if I differentiate cos, the answer is minus sine. So I'll do this. I'll put minus here and I have minus sine x divided by cos x dx. Why am I putting minus? So that if you differentiate cos, the answer is minus sine, which is up. Or better still, you can just use a substitution method. You let u to be equal to cos s, then you differentiate and put just do normal integration by substitution. You are going to still obtain the same answer. Now I have minus ln cos s. Because if you differentiate ln cos s, the answer is minus sine over cos s, which is eventually minus tan x, but this minus outside, that's why I have this actually. So I5 will then be I5 will just be equal to tan 4x divided by 4 minus I3. You see minus I3. What is I3? Tan square x divided by 2 minus I1. What is I1? I1 is minus ln cos s. So you will open the bracket. If you open this one will become plus. By the time this one will multiply it again, it becomes minus. So I have I5 to be equal to tan 4x over 4 minus tan square x over 2 minus again ln cos x plus c. You can leave your answer this way, or look at it. This ln cos s, you know, this ln is a log function. We can have ln cos x raised to the power of minus 1 over cos s is sec. So this one can also be ln sec s, but in that case, this will be plus. So this can be the answer, or we say I5 is equal to tan 4x divided 4 minus tan square x divided 2 plus ln sec s plus c. Whichever answer you arrive at is correct. Whichever way you want to give your answer is also correct. Thank you very much. We'll continue with this fourth problem, and this one we are still under calculus. So we have solved the differential equation y squared plus 2, then you have 2x plus 1 dy dx, everything equal to 1, and you are given an initial condition y of 0 to be equal to 1. So look at how we are going to be doing this. Obviously, this A part is 5 marks, 5 points. The B part is also 5 points. Then the third one is another 5 points. So let's continue. So I have this A, I have y squared plus 2. Then I have 2x plus 1 dy dx to be equal to 1. So actually we have different way of solving a differential equation, and of course this is a first order differential equation. So the good thing about this equation is that it is variable separable. What do I mean by variable separable? Variable separable means I can put the whole value of y to one side of the equation and everything about x on the other side of the equation. So that is why it is variable separable. So if you go to my playlist, you will see me where I have given or I have done summary of how to solve differential equation, first order and second order differential equation. The second order is just an homogeneous equation. It's there, and I think I'll put the link in my description box as well. So you can go through different methods, variable separable, homogeneous, exact, linear, and so on like that. So this, as I've said earlier, is variable separable. So look at how we are going to solve this. The first thing is that I will try to play a fraction, that is I'll multiply, I'll bring this ds to the other side so that I have y squared plus 2, then 2x plus 1 dy is equal to ds. After that, the next thing I'm going to be doing is that I will bring this 2x plus 1, I will divide both sides by 2x plus 1 so that I will have y squared plus 2 dy to be equal to ds divide 2x plus 1. That's what I'm going to have. Now, this is what I am saying variable separable. If you look at the left hand side, you have y squared plus 2 dy. And if you look at the right hand side, you have dx over 2x plus 1. So that's what I'm trying to say. It is variable separable. The whole of y is on the left hand side while the whole of x is on the right hand side. So I will then integrate. Integrating both sides, I have integral of y squared plus 2 dy. That means I'm integrating with respect to y is equal to integral of dx over 2x plus 1. By the time I integrate this, if we integrate y squared, you have 1 over 3 y raised to power 3 plus 2. Whenever you are integrating a constant, you put the variable you are integrating with respect to. So if you integrate 2, you have 2y. And this is equal to, now this one, whenever you have numbers like this, integral of 2x plus 1, basically you can use substitution, or in the previous question I solved before now, I told you whenever you you differentiate the denominator and you have the numerator, the integral will be the ln of what is at the denominator. If you differentiate the denominator, you have 2. Differentiate 2x plus 1, the answer is 2. So I can write this as 1 over 2 integral of 2 over 2x plus 1 dx. So if I differentiate 2x plus 1, the answer is 2. So I have 1 over 2 ln of 2x plus 1. That's what I'm going to have. So when I integrate this, the answer is 1 over 2 ln of 2x plus 1. And don't forget, whenever you are done integrating, you have to add your constant plus c, where c is a constant. Now, at this junction, I have solved the differential equation, that's all. But now we are given an initial condition, y of 0 equal 1. So the purpose of this initial condition is for you to be able to find the constant. So to find that y of 0 equal 1 means, y of 0 equal 1 means when x is 0, what is x? When x is equal to 0, y is equal to 1. That is what it means. So we put it in this differential equation. So that means I have 1 over 3 y raised to power 3 plus 2y squared plus 2y. I am putting y to be 1 instead. Let me put it directly. 1 over 3 multiplied by 1 plus 2 times 1 is equal to 2 is equal to 1 over 2 ln of x is 0. 2 times 0 is 0. 0 plus 1 will give me 1 plus c. So this is 1 over 3 plus 2 to be equal to ln of 1. Ln 1 is 0. You can confirm from your calculator. So 0 times half is still 0. So that means on the right hand side I am left with c. So that means c is equal to 7 over 3. So therefore, the answer to this differential equation, you will come back to this expression 1 over 3 y raised to power 3 plus 2y to be equal to 1 over 2 ln of 2x plus 1, then plus c. For c, we have calculated c to be equal to 7 over 3. So you can leave your answer this way. You might decide to leave it in other form. Just make sure the form you are leaving your answer is correct. So you can divide to clear the fraction, multiply through by 6. If you do that, it's still correct as well. So whichever one you are doing is fine. And that's all for this particular question. Let's come to the second one. So coming to the second problem, well, we want to find the Maclaurin series. The question says expand f of x to be equal to sine square x as a Maclaurin series of ascending power of x in the first 3 terms. So since I have the first 3 terms, that means I can just find the first 3 terms of the Maclaurin series, then I leave the rest. So look at it, the f of x is equal to sine squared x. Now, what is Maclaurin series? Maclaurin series is a kind of power series where you evaluate or you find the power series of a function at x equals 0. That is a power series. That's what we call Maclaurin series. So that means you want to write f of s, or this is what we call power series. You have f of 0 plus x over 1 factorial f prime of 0 plus s squared over 2 factorial f prime of 0 plus s cubed over 3 factorial, then the third derivative, and it goes on like that. The next one will be x4, x raised to the power 4 over 4 factorial, f, the fourth derivative, at 0. So that's what we are going to be looking at, and we'll be able to write the first three things according to the question. So we have f of x, of course, is sine squared x. So f of 0, that means you put 0 here. That's sine 0 all squared. Sine 0 is actually 0. 0 squared is still 0. So differentiate f prime of x. When you differentiate this is full sine x cos x. I mean, you can just use your chain rule. Let u to be sine x. That means you have u squared. Divide u will be 2u. Then by the time you differentiate u, you have cos x. You can confirm this. Just differentiate. You will get 2 sine x cos x. So f prime of 0, you see. Basically, this is how you do power series, especially Maclaurin series. These are all what I need. I have gotten f of 0, the answer is 0. F prime of 0, that is 2 sine 0 cos 0. Sine 0 is 0, so if 0 multiplied by anything is 0. So I have 0 as well. You can see that. Now, let's obtain, before I obtain the second derivative, because if you look at the first derivative, I have 2 sine x cos x. If I'm going to differentiate the second, find the second derivative, I'll be using product rule. But I don't want to use product rule because it will make my solution more cumbersome. So I will use a trig identity. Whenever you see 2 sine x cos x, if you remember from trigonometry, this is exactly sine 2x. This is an identity. This is a trig identity from trigonometry. Now, I will differentiate the second time by f prime prime of x. If I differentiate this will become 2 cos 2x. So I find the second derivative, f prime prime of 0. So that's 2 cos 0. Cos 0 is actually 1. 2 times 1 will give me 2. So that is what I have. Then the third derivative, this one will give me minus 4 because when you differentiate cos, you have negative sign. So minus 4 sine 2x, and I have f prime prime, that's the third derivative of 0. Of course, sine 0 is 0, cos 0 is 1. So whenever you have sine, know the answer is 0. When you have cos, then the answer is 1. So this will be 0 as well. The fourth derivative, how do I know where I will stop? This is minus 8 cos 2x. So if I find this one will give me minus 8 as well. So look at it. They want me to at least find the first three things. So you see that this first one is 0. This second one is 0. So anyone that has 0 does not count. So this is 0, this is 0. So this 2 is the first one. This minus 8 is the second one. You will see what I'm saying by the time I'm writing it out. So this minus 8 is the second one. So I just need to obtain the third one, then I'm done. So the fifth derivative, this is 16 sine 2x. f5 of 0, it will still be 0 as well. Now f6 of f, this one will give me 32 cos 2x. So f6 of 0 will then be equal to 32 cos 0 is 32. So since I have gotten three numbers that is different from 0, I just stop there. So what do I have now? This is what I'm going to have. F of s, that is sine squared s. I want to write Maclaurin series. You see, it's f of 0. F of 0 is actually 0. See that? Plus f prime of 0 is 0 as well. So it's 6 plus 0. Now f prime of 0 is 2. So I have s squared over 2 factorial multiplied by 2. Now f, the third derivative is 0. The fourth derivative is minus 8. So I have plus s raised to the power 4 over 4 factorial multiplied by minus 8 plus s raised to the power 5 over 5 factorial divided by f5 of 0. This one is also 0. Now f raised to the power 6 This one is 32. So I have plus x raised to the power 6 over 6 factorial multiplied by 32. And it goes on like that. You will see that actually that's what the first three terms we have. F of x is equal to 2 factorial is 2, so 2 cancel 2, you'll be left with x squared. So I have x squared, then this one, 4 factorial is basically 24, so 8 divided by 24 is 3, minus 1 over 3 x raised to the power 4. 6 factorial is 720, 720 divide 32 well, let me just write 32 over 720. You can just use your calculator to just arrive at your answer in this case. Then you write all of those. So it goes on like that. So this is the first three terms of the power series, and that's all for the first question. Now let's come to the second question, B. So look at the second question. 60 meters of fencing is used to form 3 sides of a rectangular enclosure. Now the first side being an existing wall, then we are told to compute the length of the rectangular enclosure in terms of the breadth. The length of the rectangular enclosure in terms of the breadth. And the second one, the maximum possible area of the enclosure. That is what the second question is saying. Actually, this is an application of differentiation. Now, we are told that they want to do a rectangular enclosure. When they are talking about rectangular enclosure, you know what a rectangle is, and they told me that the fourth side is already an existing wall. So, draw the wall first. Let's say this is the wall, right? This is the wall. Then you have 3 other sides. So let's say this is the rectangular enclosure that they want to talk about. Then this side is the wall. So you need to draw the diagram in this case so as to be able to see so that you can be able to see what you want to do. So this is the breadth. This is the breadth. Now this is the length. So I have area, then I have breadth, length. So basically, this is what they are trying to say. I have L plus 2B, this length, and this 2B. That is what we are using to fence. It's equal to this 60. It's equal to this 60 meters. So look at it. 60 meters of fencing is used to form 3 sides of a rectangular enclosure. That's why I have L plus 2B. That's what they use to form it. So the first question that says that the length of the rectangular enclosure in terms of the breadth, just make the length the subject of formula. So length will be equal to 60 minus 2b. That is the length. That's the solution to the first question. Now, let's talk about the second one. They want us to get the maximum possible area of the enclosure. To be able to find the maximum possible area, you have to know the area of a rectangle. The area of a rectangle is length times breadth. Length times breadth. So area is equal to, we know what the breadth is. The breadth is 60 minus 2b. Then the length is 60 minus 2b multiplied by b. So I have 60b minus 2b squared. So in order to be able to find maximum area, at maximum area or even at minimum area, the y/s will be 0. So we'll differentiate this with respect to b. So I have the AB. Differentiate 60b, the answer is 60, minus differentiate 2b squared, the answer is 4b. So this is what I have. So at maximum area, the y/s or the ADB will be 0. So at maximum area, the ADB will be 0. So I have 60 minus 4b is equal to 0. That's what I will have. So I will solve for b. 4b will be equal to 60, and eventually b will be equal to 15 meters. So, and I'm actually done. If you take the second derivative test, for a point or to be maximum, At maximum area, the square A over the B square must be negative. If you take the second derivative, you have -4, which is negative, and that's it. Since I only have one answer, like just one value for breadth, so that is the value for maximum area actually. So I have gotten B to be 15 meters. I need to find the length. Length is equal to 60 minus 2B. That is 60 minus 2 times 15. That's 60 minus 30. The answer is 30 meters. Don't forget, I have just found the dimension. I found length, then the breadth. So, but they want me to find maximum possible area. So, area is equal to length times breadth. That is 30 multiplied by 15. So, you use your calculator to do this. This is 450 meters squared. That is the maximum possible area for that rectangular enclosure. So, and that's all about the question actually. Let's come to the third one. So, the third one, find the volume generated when the plane figure bounded by y equal to cos 2x, the x-axis, and alternate at x equals 0 and x equals pi over 4. Rotate about the x-axis through a complete revolution. So now basically, look at what they are talking about. We want to find volume, and the truth of the matter is that this particular concept is on application of integration basically. This is the x-axis. Why this is the y-axis. Now, of course, they said it is bounded by the x-axis. This is the x-axis, so that means it's something here. This is the x-axis, basically. And you have y equal to cos 2x. If you know how the graph of cos 2x is, it's still the same thing, only that some things will just change. Cos 0 is actually 0. If you want to draw the graph, this is how it will look like. That is a graph of cos x. But since it's cos 2x, I will just 2 cos 2x. This place will be 2. Yes, this place will be 2. And now, where cos 90 is 0, so that means when x is 45, that's pi over 4. It's at this place, I have pi over 4 here, and on this place I have 0. So basically, they want us to find the area here. That's what they want us to find. The volume rather, the volume here, the volume of this shaded portion of the graph. This is what they want us to find. Now look at it. They want to find the volume here. That's why they say it's bounded by the x-axis between 0 to pi over 4. It is from the question, and y equal to cos 2x. This is the graph. So now, how do you find volume? Volume of revolution. Volume is actually equal to integral from a to b of pi of f of x all squared dx. That is what we are. That's the formula we are going to be using to solve this question. Now, of course, a to b is from 0 to pi over 4. That is the bound of the integral. That's integral from 0 to pi over 4 of pi. Then I have 2 cos 2x all raised to power 2 dx actually. So that is what I have. So what do we do from there? This is equal to pi is a constant. It can come outside the integral. So I have pi integral from 0 to pi over 4. Then I have 4 cos squared 2x dx. 4 can also come out to become 4x integral from 0 to pi over 4 of cos squared 2x dx. So, in order for us to solve this cos squared 2x, don't forget, remember the identity I did in the previous question as well. The identity says that when you have cos 2x is equal to 2 cos squared x minus 1. If you make cos squared x the subject of formula, you will have 1 plus cos 2x divided by 2. Actually, that is what you are going to have. Now, since I have cos squared 2x, just anywhere you see x, replace with 2x. So I have cos squared 2s to be equal to 1 plus cos. Now I have 2s already, I have 2, then I replace that x again with 2s. So 2 times 2 will give me 4. So I have 1 plus cos 4x divided by 2 actually. So the volume of the integral, the volume will be equal to 4 pi integral from 0 to what? Pi over 4. Then cos square 2x is actually equal to this 1 over 2, 1 plus cos 4x ds. So to finish this 1 over 2 will come out to become 2 pi. If you integrate 1, you actually have x plus integrate cos 4x. The answer will be 1 over 4 sine 4s, and we start from 0 to pi over 4. So now, if you are not sure of the integration, differentiate 1 over 4 sine 4x, you must get cos 4x. If you don't get cos 4x, that means what you have done is not correct. So when you are integrating, you also need a strong knowledge of differentiation alongside. So I have this. Now put the values. B is equal to 2 pi. Anywhere is here, 2 pi over 4 plus. Now sine 4 times pi over 4. 4 times pi over 4 will give me sine pi. Sine 180 is actually 0. 1 over 4 times 0 is 0. So if you put 0 there as well, it will still be 0. So you will just left with this, and the value of that or the volume of revolution will give me pi square over 2, and that's the answer. Pi times pi will give me pi square, 2 divided by 4 will give me 2. So I have pi square over 2, and that's all.